Hey everyone. So we're going to move on to our next section of algebra, which is a general rule and pattern we see emerging with various questions in this topic. And this is what's called the distributive law. Now, some other people, you may have heard it as expanding the brackets and stuff like that, but the main way we do this particular strategy is we apply it when we have brackets here. So I'll give you the first question here. And once again, we're going to do it quite short. Well, sorry, I should say we're going to do it quite long form. So I'll work through this quite slowly, hopefully give you a little bit of the intuition, and then we'll come up with a general formula to apply for any questions of this sort. So I have here 5 outside of x plus 3. So this 5 is outside of the brackets. Now, you may remember from before that when we write things next to each other in algebra, so for example, we write 3x, what's implied here is that there is a multiplication going on here. Now, the same thing happens with brackets here. So this is like we're taking 5 lots of this bracket. So some of you may remember back in primary school where when you think of when you're first starting to get introduced to multiplication, you thought of this as lots of. So if you did 2 times 4, for example, you'd say, I have 2 lots of 4. We're going to be talking about this same similar kind of idea when we do the distributive law or expanding these actual brackets. So all I have here, all I'm essentially saying is I'm taking 5 lots of this number x plus 3. We don't know what the number x plus 3 is, but we know that when I write it in this particular way, I'm taking 5 lots of that. So I'm timesing 5 by x plus 3. Now, when we multiply, that's like saying x plus 3. We're taking 5 lots of it. So we're taking x plus 3, adding it to x plus 3, adding it to x plus 3, adding it to x plus 3, and adding it to x plus 3. Now, once again, I'm going through this quite slowly here to hopefully get you quite comfortable with with how we establish this rule in the first place. Because we're just going to do a couple of questions in this way, see if we find a pattern, and then apply this to all brackets that we need to expand. Now, would we agree that this thing up here is exactly the same as the thing down the bottom? We're taking 5 lots of x plus 3. So we have 1, 2, 3, 4, 5 lots of x plus 3. Now, what do we have here? Well, we have a couple of like terms. So we have an x here, we have an x here, an x here, an x here, and an x here. So using my algebra knowledge, I know that x plus x plus x plus x plus x equals 5x. I'm just collecting the like terms here. I have 5 lots of x. And I have these 3's as well. So I have 1, 2, 3, 4, 5 lots of 3. So let me write it down the bottom here. I have 3 plus 3 plus 3 plus 3 plus 3. And that gives us 5 lots of 3. 5 times 3 gives us 15. So when we expanded this, 5 outside of x plus 3, I got 5x plus 15. Okay, now I want to see if you can see anything interesting that's happening here. Because to me, getting 5x, would that not be the same as if I just multiplied 5 by x here? Now this 15 here, let's color coordinate that differently. This 15, did I not just get that from timesing 5 and 3? So we got this solution. Now, I took a very long way to get it to hopefully give you a long form, we like to do it on this channel, a really long form, slow investigation of the concept. Now, we saw that when we took 5 lots of x plus 3, we did this whole massive thing, and we ended up with this, which is kind of the same as 5 timesing by x, and then adding that to 5 timesing by -3. Now, that may have just been a coincidence, so let's test that with another question. So the question I'm going to do here is a outside of a minus 4. Okay, I'm going to do this in the same way. It's going to take a little bit of writing, so I apologize here. But taking 8 lots of a minus 4 is like going a minus 4 plus a minus 4 plus a minus 4. Let me pick a smaller number because it's annoying me just writing it in. Let's say we took, let's say we have 3. 3 outside of a plus 4. Let's do that. That'll save you some time and patience here. Now, let's see what we've actually done here. Once again, we have 3 lots of a here. So we have a. I'm going to group these all together. A plus a plus a. Because when we add, it doesn't matter which order we add these things here. I don't have to go a minus 4 plus a minus 4 plus a minus 4. I can just first add the a's together. It's the same as when we have, for example, 3 plus 5. The solution I get is the same as when I do 5 plus 3. So the order doesn't really matter because I'm going to get to the same answer. Now, here, let's look at what I'm doing next. I'm adding minus 4 plus minus 4 plus minus 4. Would we agree? So we have 1, 2, 3 lots of minus 4. And it's the sign, the positive or negative, is kind of important here. But we're adding these, as we can see here and here. So all of these are going to be additions here. And I end up with a plus a plus a plus minus 4 plus minus 4 plus minus 4. Now, these things here, these a's here, I end up with a plus a plus a. Collecting like terms, we get 3 lots of a. Now, I'm adding that to minus 4 plus minus 4 plus minus 4. So when we add a negative number, we are subtracting by that number. So this particular thing here, minus 4 plus minus 4, that's the same as minus 4 minus 4 again. So that gives us -8. And then minusing another 4 from that gives us -12. And we are also, well, we can't neglect this plus sign. So I've separated this into 2 sections. So I have 3a plus minus 12. And then once again, I have a positive and a negative. So I'm going to get a negative. So my final answer is going to be 3a minus 12. So looking at this again, I have 3 outside of a minus 4, which gives me 3a minus 12. But what's actually happened here again? Well, look at these numbers. 3a, I got that from multiplying this outside term by the first inside term. 3 times a just gives me 3a, written shorthand in algebra. And negative 12, I get from timesing 3 and minus 4. So when I expand these brackets, we've noticed a pattern here between this and the last question, is that when I expand, I am multiplying my outside term by the first inside term, and then the second term inside the brackets here. So let's make a general rule for this, and then we'll try one more trickier question, because the questions aren't always going to be this nice. But now that we have a formalization, now that we have a type of formula that we can use, it makes harder questions far more easier. Now, the distributive law tells us that a number A, and I'm writing pronumerals here to represent any number. This will work with any number. So A outside of B plus C equals AB plus AC. So what have we just done here? Well, we have just applied the patterns that we've been noticing to all numbers. Now, we get these two terms, once again, from multiplying the outside by the inside. Sorry, let me actually color coordinate this so it makes a little more sense. Green with green. The term outside the brackets, the term multiplying by the brackets, is timesing by each of the terms within the bracket. In the same way that, and sorry, not in the same way, but we can see that this happens from our two examples earlier, that the term outside multiplies by each of the terms inside. All we've shown on this right-hand side is that AB we get from timesing A plus B. That's why I've drawn in that little arrow to show the A multiplying by the B. And we get AC, positive AC, from multiplying the A by the positive C inside the brackets. So this is our distributive law. And this is how we've come to identify it. Now, let's do just one more question to really drill this home and see that no matter how tricky these get, we can still use the same tools we have just established. Now, I've got a lot more pronumerals here, but it doesn't really make it or it does make it harder, but there's nothing to be worried about. We can approach this in the same way. Our distributive law tells us that we're going to get the answer to this. We're going to expand our brackets by first multiplying 5a by my first term in the brackets, and then multiplying it by the second term within our brackets. So this, from our distributive law, we can solve. Let me leave the distributive law up here so you can refer to it as we go. This gives us 5a times 3p plus 5a times minus 7q. Cool. Now, we've once again referred to our distributive law. Now, this is going to be a bit of revision for multiplying algebraic terms. If you don't know this, you can go back to an old video that I've posted. But this thing here is going to simplify to 15 AP. And this thing here is going to simplify to minus 35 AQ. Now, still have this plus sign. So let's put that there. And once again, I'm adding a negative number to the 15 AP. So that's just going to be the same as just subtracting that number. So the final answer we get is 15 AP minus 35 AQ. That's the distributive law summed up, and we can apply this to any question of this sort. No matter how crazy the pronumerals or numbers get, they will always follow this particular pattern. Thanks for watching, guys. I'll see you next time.